It's a great pleasure for me to introduce our speaker today, Dr. Victor Kuperman. Well, actually, this is my second time introducing him after I was given the honor to introduce you for him at Applied Linguistics Symposium here at MSU earlier this year. Dr. Victor Kuperman is an associate professor in the Department of Linguistics and Languages at McMaster University. And he's also a Canada Research Chair in Psycholinguistics and the director of the Reading Lab, which is called the Research Center for Advanced Research in Experimental and Applied Linguistics. Dr. Kuperman's main interest is in reading, how people acquire reading, what obstacles some readers face when acquiring the skills, and why. The pursuit of his interest led him to specialize in several areas of psycholinguistics and quantitative linguistics. And his interest also extended to examining cognitive, oculomotor, and computational aspects of eye movement behavior in reading and individual differences in literacy acquisition and text comprehension. Recently, his endeavors advanced to building a new corpus called the Multilingual Eye-movement Corpus, MECO, which is the product of an international multi-lab collaboration of research groups that includes a rich eye movement record of text readings of speakers of 12 languages in their L1 and English. Today, Dr. Kuperman will discuss his recent research on MECO that provides novel theoretical insights into the nature of L1 and L2 reading. So please join me in welcoming Dr. Victor Kuperman.
Thank you so much for this lovely introduction. The second one this year. So you must like the work that I'm doing, because is the second time indeed I'm presenting at your university. I'm very happy to be here virtually. Hopefully at some point we'll graduate to in-person visits. I will indeed be talking about the MECO corpus, and what I did not realize is that you've read the papers, apparently the MECO related papers before this class. So let's keep this as informal as it can be. You know, you're graduate students. I teach graduate students. I have a very similar class to this one. So feel free to interrupt. Feel free to tell me that I'm going over stuff that you've already read in the papers or know from the previous talks. I'm happy to navigate the time that we're given in the most useful way. At this point, I plan to talk for about maybe 50 minutes and to leave the rest for the discussion. Like I said, feel free to jump in and interrupt and sort of ask questions along the way. So the MECO, right, a little more about the background for this specific presentation. I was told to talk about MECO with an emphasis on the nuts and bolts of the eye tracking trade, as it were. So we'll spend a little more time on the nitty-gritty details of that. And I was also asked to talk about the challenges that came with organizing a fairly large project of this sort. So I'll concentrate on these two sides of things, but yeah. Well, starting with an organizational aspect, I don't know how pedagogical it is, but truly the idea of MECO that I will share with you in a second, the rationale for even starting this project came about from, well, a realization that there are very few corpora that satisfy the data requirement that we would want to have in the field, right? If we want to make progress, if we want our models, theoretical or computational, to be generalizable over multiple languages, we better have the data that satisfy the testing requirements for these models. So that was the rationale. The actual implementation started over beers at the Psychonomic Conference in New Orleans in it would have been 2019, so about well, a little over 3 years ago. So we had Noam Ziegelman, the person you see here, the co-lead and co-director of this project, and myself. We started off with private conversations on what kind of data we would like to have, right, in order to fulfill our internal mandate for cross-linguistic research. And then soon after, indeed, at the meeting of the Psychonomic Society in New Orleans, we realized that there is a very strong bunch of eye tracking researchers right there in the same hotel at the same conference. So even during that conference, we talked to them and got the critical mass of researchers who agreed to participate, and that was sort of the kernel, the core of the MACO project. Many more labs joined us since, but we already had the bargaining chip of saying, look, 5 people have agreed. Why don't you become number 6 or number 7 and join the project in its first iteration? So so the idea indeed was to start with to create a data set that would help us paint a broad typological picture of reading behavior across languages and writing systems. And in one of the papers that you might have read, we even had a bibliometric analysis showing that it's hard to find a paper that even has 3 languages with eye tracking data in comparable manipulations, comparable technology, and so on. So yeah, it was exceedingly clear that we need to step up our game. So from the beginning, MACO had 2 components in its conception. We wanted the L1 and L2 components to it. Now, for L2 to be as universal as it possibly can, we picked English. There are some thoughts of maybe doing an L2 spin-off that would have either Spanish or German or French, one of the languages that are also broadly spoken and broadly learned. But at this point, we are looking at L2 English specifically. And from the get-go, we wanted the same participants to do L1 and L2 tasks because we want to know the link between the two, right? We want to know how proficiency in L1, especially the eye tracking behavioral signature, how it translates or not into the L2 behavioral eye tracking behavior. So so far we've published data on 13 languages, all of which are alphabetical, well, with perhaps an exception of Hebrew, which uses an abjad writing system. Of the alphabetic languages, Korean is perhaps the most outstanding one. Very much an alphabetic system, just visually very different from the rest. The remainder of the languages, as you will see in a second, are Roman-based, Cyrillic-based, Greek, and so on. Now, across all samples, we wanted to maintain comparable readership, right? University students in their home countries reading in their home language, in their first language, plus English L2. The texts were comparable, and the apparatus was comparable as well. This was a methodological requirement for us to look at the 13 languages and have a decent degree of consensus that we're looking at similar quality of the data and similar quality of readers in their L1. So these are the 2 papers that have been published so far. And well, please take a note of the number of authors. We'll get back to that when we talk about the difficulties and the rewards of organizing multi-lab, multi-author collaborations. So the publications cover the 30 languages in wave 1, what we call wave 1. The name came before the pandemic, so we didn't mean any. There was no connection with the waves of COVID-19 that everyone talked about since then. The project precedes the pandemic, and really all the data, we were very lucky to have collected most of the data that we wanted in wave 1 before the labs closed for the pandemic. The samples that we got were a little smaller than we wanted. We counted on 50 to 60 participants in each lab. We ended up with 40 to 50 in most labs. So sort of the very tail of data collection was cut off by the pandemic, but we decided to move ahead and with the publication of wave 1 and these are the 13 languages that it contains. Korean is the only language that we have only L1 data from, so the limitations of that partner site were such that they could not sustain the 2-hour session for L1 and L2. They only did the first session. And of course, given the choice, we said, well, collect the data in your L1, right? We can always come back and find L2 speakers, but it's more important that we have the L1 data from you. Now, since the pandemic, right, a few more samples were collecting data before the pandemic, but were cut short. So now that the labs reopen, we are looking at a very exciting wave 2, which will have Arabic and Basque and Catalan and two flavors of Chinese, two systems of Chinese writing. We'll have Hindi and a few more European languages. So that will expand the spread of both the types of oral languages, but of course, but also of writing systems. So Arabic will be in the same category as Hebrew in terms of the writing system. Chinese, of course, is a logographic language, and Hindi is its own kind, the Abugida kind, the alpha syllabary language where characters stand for syllables, give or take. Yeah. And then, of course, we're adding a few more Roman-based languages to the mix. With MECO, we're committed to continue going and growing as long as there are people who want to join. Okay? So we will be cutting the waves sort of time-wise. So for instance, for wave 2, our break is the end of this calendar year. Whoever has completed the sample of 50 or more good participants by then will make it into wave 2, but other samples are very welcome to continue or join later on. They will hopefully constitute wave 3 and so on. Along the way, we will be publishing updates to MECO, and these updates will be of two kinds. There will be new samples added, hopefully, and for some of the languages that from previous waves, in this case just wave 1, if we can collect more data and sort of supplement our samples and give them to a larger size for statistical power and all the other good things. If this happens, then we'll be publishing these updated samples in new releases. Okay, now more languages or samples are always invited, and this is true both of the new languages that would join the project, and also it's true of the samples of the same languages that we also already have the data for. And indeed, in wave 2, I didn't list them, but we will have an additional German sample, an additional Russian sample, and an additional Spanish sample. And this is very important and critical because if you think about it, as long as we have one sample per language, this sample, say, McMaster University in Canada, is the representative of the English language in the universe. Now, this, of course, is not true, incorrect. And we cannot tell apart differences between specific universities, cities, countries, regional variants, and when there is only one sample representing that country or that language. So we're extremely happy when more samples of the same languages join in. So please consider this when you think about MECO. All right. So as far as specifications go, we always try to limit our partners and ourselves to the undergraduate university students in their home countries. So L1 speakers of the language that we tested. We have a small percentage of graduate students or people who have just graduated from their degrees, but we're still around getting credits or getting some money for their participation. But overall, that worked pretty well. For their L2 component, for it to be more or less representative of how students in a given country operate in the English language, we ask our partners not to include not to include native speakers of English, period, right? So say in Finland, we didn't want native English speakers to be part of the sample. We also try to limit the sample to those individuals who have not lived in an English-speaking country for more than 6 months. It's an arbitrary threshold, but we just didn't want people with extensive exposure to the English language to skew our data in the favorable way, as it were. Now, of course, everything that I will tell you about the L2 data needs to take into account that we're looking at proficient L2 speakers, right? They are students at a university in their country. Typically, they have to go through one or multiple tests for English proficiency. Depending on the country, much of their reading materials will be in English. Some of the studies will be in English, even though we made sure that we did not recruit anyone from a program where English was the medium of instruction, the language of instruction. Okay, so MECOL1 had 12 texts in the native language of the readers. Since you asked about the technical details, we had to spend some time and brain energy on finding topics that are not, let's put it this way, not overrepresented in some country or some language, perhaps. So, for instance, if we would ask people about, I don't know, curling or ice hockey, right? Countries like ours, right? US and Canada would have more knowledge about this than, say, Serbia would, or Italy, perhaps. Right? So we picked texts in the Wikipedia genre that were more or less neutral, right? Plants, animals, historical figures, and so on. So the texts were followed by yes/no comprehension questions, and we would take an English text and translate it into specific languages for half of the texts. So here's an example of English and German, Hebrew, Turkish, and Russian. And then we'd have another half of the text, more or less, where we would pick a topic. We would ask everyone to write a text on this topic of approximately the same length, but not a translation. And this is just so we could have the syntactic diversity and the lexical diversity and the originality of the language that is not superimposed with the English influence, with the English structure. Right? So all texts were comparable to some degree. About half of the texts were very comparable because they were translations, and another half were of the same topic, of a similar length, and a similar number of sentences, and so on. But yeah. For MECO L2, we took texts in English from a college placement comprehension test. AccuPlacer, if you want details, that's the name of the test. And here's an example of a text. These are pretty short, and some of the questions followed that tapped into factual or inferential knowledge, inferential understanding of the text, and so on. Now, for the test, I'll return to M1 for a second. We only ran one test across all L1 participants in all sites, and that was the test of nonverbal intelligence, the culture fair test. We translated instructions into respective L1s, and this is the test that we just wanted to have across all labs to make sure that we're not looking at massive differences in nonverbal intelligence between students, right? So it would be based on pictures exclusively, like this one, and indeed we did not find any massive differences at all across participants. In the L1 part, now because we're dealing with very different languages, the verbal tests varied from one site to another. We encourage people to use the test that they have for the language, and most used either vocabulary or decoding or spelling and whatever they had available for their language. But there was no way to insinuate, right, to impose the same kind of test across all languages because, if you think about, say, decoding, right, Finns would excel in it because it's such a transparent system that with effectively one-to-one correspondence of graphemes and phonemes, right? So we had to go with whatever our partners decided to include. For the English part, of course, we had a choice and we included a small number of tests, but they worked out fairly well. Again, a vocabulary test, spelling, decoding, and only one or two others. Let's talk a little about the technology of the corpus. So in all labs, we used iLink machinery, 1000 or 1000 plus at that point. One lab has iLink 2, but the uniformity of the apparatus made it possible to share the actual experiments, built an experiment builder. So we were always looking at the same protocols, right? The same experiments. Only the text would be replaced by the L1 text would be replaced by the respective texts. One thing I should mention as well, let me scroll back to the L1 section. The translations, right? How did we know these were good translations? So we had them back translated to English by a different person from the one who made the original translation. And then we would look at it and occasionally go back and forth to make some changes. And that's how we made sure that the quality of translations was decent. For paraphrase texts, right, which are a topic we still requesting back translations, there we just made sure that they were indeed on a similar topic and there was nothing very off content-wise in those. Okay. So back to the technology. So we used experiment builder and data viewer. The tests of individual differences, some were computerized, some were run online, some were paper and pencil. For eye tracking data, we used PopEye software for data cleaning, graciously provided by Sascha Schroeder at the University of Göttingen in Germany. And this is what allowed us to save quite some effort on aligning vertical alignment of fixations against the lines of text. So again, I'm happy to take questions. So we talked about this. Here are the tests that we administered in the L2 part. First of all, we ran a fairly extensive LeapQ questionnaire, language experience and proficiency questionnaire for L1 and English, just these two languages, to get an understanding of both their subjective evaluation of how proficient they are in these two languages, when did they come about learning English, and all of these good things. For individual differences tested in English, we had Towery word ID and word attack. So decoding sight word efficiency, vocabulary size, spelling, lexical decision, for which we use LexTail test available online. We also had a motivation scale. Now, this is not a motivation to learn a language or to speak English. It's a more motivation for excelling in the task. Right? How engaged were you in the task? Again, right. So overall, 2 hours of testing were necessary to go through L1 and L2 and the test of individual differences. We targeted 50 participants after data cleaning, meaning 50 good participants, right? Once we take out the ones that came with calibration errors for eye tracking or didn't perform very well, that was our target. In all but the Korean sample, we had a within participant L1, L2 data. And so we're looking at 580 participants from 13 language samples. All data are freely available. We are adding new releases of the data. At this point, we're just adding minor changes, right? Occasionally we find that something went wrong in this or that sample, and we would recalculate the data and make it available. Big changes, big releases will come when wave 2 is prepared and several more languages are added. But all of these again are made available in real time. So you get trial level interest area reports and summary files. So depending on the research question you have, you can sort of tap into specific data representations. All of them are of course based on the same eye movement record, and we make available the results of individual difference tests. Right. So I know that this is an eye tracking course, so I don't perhaps need to spend a lot of time on explaining what the different variables stand for. We use the fairly standard package of, fixation durations, cumulative, both individual cumulative, such as gaze duration or total fixation time. We recorded and made available SICAD positions for those of you who are interested in the ballistic aspects of eye movements. Of course, skips, regressions, refixations, all of these were included in the reports, and some of these were looked at. Right? So it's both an advantage and a disadvantage of this corpus is that no single paper can do everything, right? So even the introductory paper, as long as it just scratched the surface, right? It reported descriptive statistics, it made some very basic analysis. The rest, what we hope for, is that the rest will appear in follow-up papers. So, right, so I described the word level. We also provide data on the sentence level, reading times per sentences. You can also study reading dynamics throughout the sentence. For instance, is there something like a wrap-up effect where people read a little slow down towards the end of the sentence and so on. Again, data is available. We haven't looked at it. So if you're looking for projects, by all means, use the data. At the passage level, so one can look at eye movement patterns against comprehension, right? So this is something that, of course, Aline Goldfreud has done fabulously in her learning studies. Right? So what kind of eye movement patterns lead to good learning, or lead, in this case, to good comprehension? One can use ScanPath, something I'll happy to answer questions if you have any later on. So so that's sort of the scope of the data that we make available. Now, let me stop for a second and ask you if you have any questions so far. We have the luxury of time and small group.
I think everybody's still good over here.
Okay, let's go on then. So I just want to give you a few illustrations of the descriptive statistics and how it can be used in this case to look at L1 differences and differences in L1 reading. Now, this is almost impossible to read, so I'll just zoom in on a couple of examples. So we're looking at skipping rate in the left panel and total fixation time in the right panel. What you have on the vertical axis for skip is the percentage or proportion of words skipped. What you have on the horizontal axis are the different languages in the alphabetic order. I highlighted English on top there in a oval, in an ellipsis, and I highlighted German just because my last talk was in Germany, so I think that's the reason. So as you can see, English readers skip much more than anyone else, right? Significantly so. You have error bars representing standard errors. Dutch and the Dutch and the Finns are always very close to the English readers. So if we had to put our money on which samples show the behavior that is the closest to one, it's almost always the Dutch and the Finnish samples. All the rest of the languages are pretty much in the same band with a lower skipping rate. Now, total fixation time, of course, is a different beast, right? We have English in the bottom here. So Canadian native English, native readers of English spend the least time, total amount of time on a word. They're followed by a band of other languages, including German. here you can see that the one on the top, the one that takes the most time, is Hebrew. Then there's Italian and Turkish, and so I can't quite make out my own label, so I apologize. I don't know what this pink one stands for. Spanish, that's what it is, right? So so even this descriptive statistics gives us an idea of the spread of values, and it's not surprising, of course, that L1 readers show. Sorry, I apologize. I said it's L1 reading data. It is L2 reading data. So everybody's reading in English, and we're comparing people reading the same text. Sorry, I misspoke. So so English L1 readers show signs of more proficient reading. They more word skipping, shorter word reading times, and this is the spread of the values is one of the many ways to look at the reading proficiency of other L1 readers, other L2 samples. Here's a look at the skill tests. So again, all of these were done in English, right? We have a spelling test, Tauri non-word, Tauri word, and vocabulary. And in all of these panels, you see English native readers, L1 readers on top, and the German sample slightly behind or a lot behind. And it's very easy to see that almost invariably in all these domains, native speakers perform better than the L2 speakers of English. Right. We found no difference between samples in nonverbal intelligence or motivation, which is reassuring. So we're looking at generally comparable samples. So what that means that the differences that we're researching here have to do indeed with mostly their L2 proficiency than with any other extra linguistic domain. Okay, so looking at looking at correlations between an individual performance in skill tests and individual eye movement behavior, we can do away with the L1, L2 distinction, right? Because everyone has done the same test, and we have eye tracking data from everyone, so we can just correlate their these type of performance with this type of performance. So what came out to be is something quite expected. High performance in any of the skill tests came with faster and more accurate reading. So we couldn't quite tell apart whether it's mostly the vocabulary or mostly the spelling. But in all fairness, we didn't administer a very large battery. This was a small battery of very interrelated tests. So one would need a different project to tell these apart. We found no correlations between reading behavior and either nonverbal intelligence or motivation. So again, just removing some extra linguistic factors from the picture. Okay. So so now that we've talked about the structure of the corpus and structure of the data, let's embark on a more detailed, zoomed exploration of what is L2 reading comprehension made of, right? So I'm sure you've seen a pyramid like this, where L2 reading comprehension is the top of the pyramid, and for it to be successful, so many different component skills and skills and pieces of knowledge have to be in place, right? Definitely L1 literacy, so one has to be proficient and literate in their first language in order to succeed in L2 reading comprehension. On top of that, one has to have fairly decent knowledge of L2 language, so the component skills of reading, everything that needs to fall into place for reading comprehension to be achieved. And then there are some extra linguistic factors like motivation towards learning a language, attitude toward language, world knowledge, general world knowledge, and as an additional factor that we won't spend a lot of time on, L1, L2 linguistic distance. How similar is your L1 to the L2 that you're performing in? Okay, so with the data that we have, we can get quite some insight into what is L2 reading comprehension made of? Or better yet, what is L2 reading made of? So we'll start with something that is not even eye tracking, it's reading rate, right? Words per minute, something that we could have done with a stopwatch. A person read a text, yeah. How much time did it take the person to read the text? So we're looking here at just the participants who are not from Canada, right? Only the samples of L2 readers of English, and we're comparing their L1 reading rate to L2 reading rate. Now, a side note here, right? If you think about it, L1, well, reading rate is calculated in words per minute. Now, it's all good and fine if you're comparing data in the same language. Words are the same. Now, if you think about comparing, say, Finnish and Hebrew, Finnish words are huge in the number of letters. Hebrew words are tiny in the number of letters for all the good reasons having to do with the writing system and the morphosyntax and all these other things. So we cannot, right? So obviously, since words are different in both their length and how much information then they encode, we cannot directly compare words per minute in Hebrew to words per minute in Finnish. So what we did, we scaled within each language, we scaled with Z-transformed reading rate, well, within Finnish and then separately within Hebrew and within all other languages, and then consider them together just to see who's a fast reader versus a slow reader. So that's why you see on the horizontal axis here, L1 reading rate scaled, whereas L2 reading rate was actually done in the natural units, right, words per minute. The point is that once you do this, you see a very strong correlation between the two reading rates. So much so that almost 55% of the variance in L2 reading rate is explained by how fast that person reads in their first language. Okay, so there are, many explanations that we didn't get to explore just yet, but one is, if let's say, of course, language proficiency can and should be shared across L1 and L2 to some degree, right? If you're better in learning your own language, chances are that you'll succeed a little more than others in learning the second language. Another interesting explanation is actually extra-linguistic, right? It doesn't have to do with proficiency, and I like this explanation a little more. Cognitive speed, right? If you're fast in cognitive tasks, you will be fast in all cognitive tasks, which will include indeed L1 and L2 reading. Now, these explanations and additional ones are not mutually exclusive. We'll have to dig deeper into the data to see who wins. All right, so with this in mind, with this strength of correlation in mind, we thought, okay, here's what we'll do. We'll take L2 reading proficiency, measured through either eye tracking or through accuracy of responding to comprehension questions, so fluency and comprehension, right? And we will look at these two sides of the coin in L2 reading in a structured way, right? So we fitted models which had a step with L1 literacy, so performance by the same participant in L1 in the same measure that we're considering in L2. We would include L2 knowledge as L2 skill test by participants, and we will add motivation and their IQ. So everything we know about this person and their knowledge of component skills and the overall sort of aptness for learning. And then we would include variability between L2 samples, also including L1 versus L2 variability. So right. So just where the arrow points, that's the reading rate. That's what we considered a minute ago as a scatter plot with the correlation. So in this variable, all variables, in L2 reading rate, all the three steps explain about 75% of the variance, and that's how they work. In step one, we add L1 reading rate, that's the orange part. The red part adds the skill test and whatever additional variable extra variance they explain. In step 3, added the L2 sample. So altogether, they explain close to 75%, and which is true for almost all of the variables here. So L1 reading rate alone explains 48%, skill test addition explains 15%. Variability between L2 samples, that's the, I guess, dark blue part on top here, only explains about 4%. So that's the difference between the Finns, the Turks, the Dutch, and so on. So it's fairly minimal. So most of the variables that are combined here under this bracket behave very similarly. And that's because these are actually eye tracking variables, right? These are averages per participant, where we would predict the L2, say, skipping rate or L2 total fixation duration from the respective L1 measures. And for all of these, we're explaining 65 to 75% of the variance. So a very massive amount of variance is explained here. So even if it's not a complete picture, we're not missing a lot. L1 performance is by far the strongest predictor. So 50 to 70% is orange, right? Meaning that whatever you do in your L1, that's the strongest predictors of what you will do in L2 as far as fluency is concerned, as far as eye tracking behavior is concerned. Much less comes from L2 proficiency, that's the red part, and only little variance between L2 samples. Now, you will notice that there's, of course, this outstanding one smaller bar, which is reading comprehension accuracy. First of all, we explain less variance here, only about 50%. L1 comprehension only explains a small part of it, right, only 12%. Much more explanatory power comes from L2 component skills. And again, L2 samples don't vary too much between each other. So if we're talking about L2 fluency, it really mostly comes from their performance in L1 reading fluency. So proficiency in English, those component skills only slightly change L2 reading behavior in the fluency domain. And this leads us to thinking that there are stable oculomotor strategies across L1 and L2. So people who are quick but have to revisit what they read many times will do so both in L1 and L2. People who are slow and accurate will tend to be fat both in their L1 and L2. And that's new and that's exciting. And that's something that we could not have known without a data set like this one. So apparently fluency has a much stronger non-linguistic component than expected. We can call it cognitive speed, we can call it executive function. We're not able to just put our finger on it just yet, but it's less about the knowledge of the language. Mind you, of course, we're talking about advanced L2 speakers, right? These are, that's a very top of the cohort in their countries, but at least within this cohort, it's mostly about the non-linguistic stuff when it comes to reading fluency. Now, accuracy is much more, in L2 is much more about L2 skills. That's where you need to build all these component skills and have them at a high enough level to achieve comprehension. So to give you an interim summary, we see cross-linguistic differences in language structure and L1 reading behavior. I didn't give you too many examples of that, but I'm happy to. L2 reading comprehension and fluency are radically different. Right? They're easy for advanced. It's easier for advanced learners to reach the former, but not the latter. L2 reading performance is predicted by L1 performance in a much stronger way than believed before. Let me stop here. Do you have any questions so far? Otherwise, we're about to move to the next thing. Yeah.
I think we have one. I'll pass the mic over.
Thank you. I just wondering what's the definition for L1 and L2 language distance. So it is defined in which aspects?
Great question. So there's several ways of defining, of operationalizing L1, L2 distance. And well, let me start with this. One can look at languages, so the oral languages and how close they are. And, intuitively, we will find that German and Dutch are closer to English than, say, Korean or Chinese or Finnish. But, and then there is a script there's a script distance, right? How close is your script to in L1 to the script in L2? And in this case, Chinese and Korean will still be very far from English, but Finnish will be very close because they're using the same Roman alphabet. So let's talk just about the oral language, right? The distance between L1 and L2 that does not look at the writing systems or So a major way of defining this distance is actually, well, it makes my heart of a linguist very happy because it uses the so-called Swadesh list. So Swadesh is the name of an American. Sorry, I'm putting the name in the chat for you. I don't know if you can see it, but it's the name of an American linguist who proposed the following. Right, he proposed a list of basic terms in every language that are like words like you, I, hand, body, food, and so on. So these are very basic words that tend to be not borrowed from another language, but native to the word stock of your language. Yeah. So if you take these lists and the words that represent the concepts into languages, you can compare how many of them are shared. Right? So if we are taking, say, English and German, you will see that the word like hand is shared, hand and hand, right? House and house, right? And so on and so forth, right? So there'll be a lot of correspondences in this basic word list between English and German. There will be fewer correspondences between English and Italian, right? These are both Indo-European languages, so some of the words will have the correspondences. There'll be even fewer between English and Finnish. There'll be virtually none between English and Chinese, and effectively, working through these lists, you can see the amount of lexical overlap between each pair of languages, and this is what tells you how distant the languages are. Now, we didn't make much of it just yet. Frankly, we're waiting for more languages to be added to MECO, right? That kind of L1, L2 distance will be of more will be more interesting when we have more languages to play with. But a long answer to your question is this, right? You can look at the lexical distance by comparing basic lists of basic words in the two languages and seeing how many of the words correspond to one another.
Yeah, thank you for clarification. I just, my intuition is that perhaps different languages share different syntactic structures, like some are SOV languages, some are SVO languages. So yeah, perhaps that also one potential factor, I think.
Absolutely. So, well, sorry to give you another long answer, but I described the lexical way of comparing two languages, but you're absolutely right. One can do better than that. One can look at the morphology and the syntax. And the way to do that is to use the World Atlas of Language Structures, or WALS, which is available online, freely available. And this is an amazing atlas that associates every language with a number of features. And it effectively describes every language in the number of features. So SOV versus SVO versus OVS, all these combinations will be present, and every language will be marked for that feature as having SVO or SOV and so on. So in this approach, how you can compare two languages or calculate the distance between them, you can look at the features and look at the number of overlapping features. How many of the features are shared out of the total, right? The more features are shared, the closer the two languages are to one another. Again, we would expect for genealogically close languages to share more features. But this approach goes beyond the lexicon. So it looks exactly at the morphology and the syntax and phonology.
Yeah, thank you.
All right. So let me move on and tell you about another project that we built on Meko. So the initial motivation for this is a long-standing observation that where the eyes land on the word is not random. So if you look at this plot, you will see letter position in the word marked from 0. 0 is the space before the word, and then you have the actual number of the letter in the word, and proportional fixations, right? And so it turns out that people tend to land close to the center of the word, actually a little to the left mostly. Well, the word, why is that? Well, you know a lot about eye tracking. That's because this tends to be a position that if you land there, if you land close to the center of the word, you will have the best view of the word, both to the left and to the right, the parafoveal preview, and you will need to refixate less. So this is a U-shape, a famous U-shape. If you have your fixation in the middle of the word, which here is marked by 0, the center of the word, your refixation probability on the y-axis will be the minimal. If you're in the very beginning of the word or the very end, it will increase. So that's the optimal position for the eye gaze for the eye to land on the word, right? Somewhere close to the center of the word. So there's actually, this is known as initial landing position, right? There's actually very little work on saccadic positions in L2, and Lynn in her book stated this very clearly. Indeed, that was true when the book was published in 2020. It's virtually the same. The situation is virtually the same now, with perhaps an exception of one paper by Parshan et al. So they looked at readers of Russian, monolingual adults and children, and highly proficient, less proficient heritage speakers, and L2 learners of Russian. And if you, more proficient groups landed further into the word and closer to the center. So these will be monolingual adults and children. And within heritage speakers, highly proficient heritage speakers would land again closer to the center of the word. Less proficient will be closer to the beginning. L2 learners of Russian fared the worst, quote unquote. They landed even closer to the beginning of the word. So that's why we can sensibly talk about the link between L2 proficiency and initial landing positions. So a master student in my lab, Daniil Gnatov, has picked it up as his topic, and the questions that he asked were the following: how proficiency affects landing position when reading L2, and also, is there a noticeable difference between specific L1s? Right, in Meko we're looking at 13 different, 12 minus Korean, 12 different L1 backgrounds, samples with 12 different L1 backgrounds who read in their L2. Is there a categorical difference between them? So the first step was to define proficiency of our readers, and what we did was we took all the English skill tests that we had, vocabulary and lexical decision and spelling and decoding and all that, and we just created a composite score giving an equal weight to every test. So calculate z-score per participant in every test, take the mean per participant, divide across all tests, and finally, when we had all participants on the same scale, we divided their scores into 12 equal-sized bins to represent the number of languages. I will explain why this binning was necessary in a second, but bear with me. So this is a distribution of proficiencies, as it were, of those Z-scores, the composite scores of proficiency across languages. Now, English is on top, which is perhaps not surprising. We have Turkish on the bottom. Now, because these are Z-scores, the units on the horizontal axis are units of standard deviation. But the important thing that we gleaned from this was that there's no categorical difference between any of these groups, right? So these are gradient changes. I mean, definitely within L2 samples, but even if we compare English and Estonian, which happen to be the two top groups, there's a lot of overlap, even if the advantage of English is clearly there. So that's important to keep in mind for for the overall thinking about MECO L2 proficiency and for this specific project as well. Another view is another sort of perspective on the same idea is to look at the languages that we have from English to Hebrew, right? Turkish and Hebrew, and the 12 groups that we're into which we placed our participants based on the ranking of their scores. And you will see that English indeed has 25 people in the first group, the top performers. But so it does very well, but it's definitely not the case that all the English readers are in the top groups, right? We have one in group number 9, and even in the middle of the range, we have a few, right? And if we look at the Hebrew, most of the readers are in the bottom groups, 9 and 8 and 9, but it's not the case that no one is in the top groups, right? So there is always an overlap within, well, between samples in terms of proficiency. Yeah. Okay, so what we did for each proficiency group, we calculated the distribution of landing positions, right, of the saccades that they send into the words with their eyes. So distribution over letters in each word length. Now, we needed to bin our participants into groups. We needed more people into each group because each individual person just does not produce enough saccades for all the letters of all the word lengths and so on. So we needed to aggregate, and that's a common practice in these studies. So as is usually the case, we got distributions that looked like normal distributions, only chopped up at the end. So very similar to what we're seeing here, right? These look like normal distributions, only with their tails cut off. So these were the pictures that we were getting as well. And we just fitted a function that estimated the best fit, mean, and standard deviation of each normal distribution. And then we could consider those means and standard deviations for each proficiency group. And we could see how proficiency affects the mean landing position. Here it is. We have proficiency groups from 1 to 12 on the horizontal axis. We have mean landing position on the vertical axis. 0 is the center of the word. And it's very easy to see that the top proficiency groups is almost at the center. So that's really where we're told the optimal landing position is, right? Every group after that moves inches away closer to the beginning of the word until the last group is about one full character away from the center of the word. So that means that the lower proficiency, less proficient readers are not as efficient in their landing positions. They land closer to the beginning of the word, which we know leads to refixations and so on. Now, one thing that I found interesting is that it's almost a linear pattern, right? Even though we did not, we did not impose linearity here at all. All we did was rank participants on the same scale and put them in the equal-sized groups. So it's interesting to see that transformation alone makes a categorical variable with groups from 1 to 12 will produce an effectively linear effect. So proficiency comes with efficiency. I think that's sort of the gist of our findings. Let me skip that. Actually, we do have the time, right? Sorry, I'm just, yeah, we do have a little time. So this is, I promise, almost the last slide, and then we'll move to a different discussion. So what we have here is refixations. And group 1 is always at the bottom. So in red or orange, right, these are the people who are most proficient, so they refixate less. And group 12 is always on top. That's the red group, or pink. They refixate the most. But perhaps most importantly, if we look, say, at words that are 6 letters long, the difference is minimal when people are at the word center. If we look at the, say, beginning of the word, the difference between group 1 and group 12 is huge. So the penalty for landing in a wrong position is much stronger for less proficient readers. So we know that it's less likely that a highly proficient reader will end up in this letter anyway. But even if they did, they would be less penalized for it than the L2 than the less proficient L2 readers. Okay, and this is true of the other extreme, the end of the word as well. So that's another interesting oculomotor observation to be had. Right, so just to summarize this part, proficiency comes with efficiency of saccadic planning and execution. Proficiency is gradient. We never found an evidence for categorical L1, L2 contrast or contrast between specific L1s. Again, we're looking at very advanced L2 speakers, but in this world, it looks like we'll do well if we look at their skills rather than at the language from which they come. Okay, and there's a link to a preprint that you are very welcome to follow up on. Okay, so this concludes the the data part of my of my talk, and I have a few things. I have a few things to share with you on the organizational part, but let me make a pause and ask if you have any questions about the data part so far.
I think we're good over here. Thank you.
All right. Okay, so lessons learned, right? What would we have done differently if we were planning MECO now? On the very technical side, we would have added more spacing between lines, right? We used 1.5 spacing, and that occasionally led to fixations, well, misattributed to the previous line or the following line. Our texts are not long at all, right? We could have easily done double spaced, and that would have reduced just this very annoying noise. Now, we would have imposed a very strict control over calibration and truly better training of arrays. Now, if you think about it, we're looking at 13 labs in different parts of the world. So there was no way at all for any single person to travel there. And so we had to rely on the partners to not only to have a night tracker, but to have a well-trained personnel to run these studies. And that differed from one site to another. We feel like if we had shown beforehand what a good or a bad trial looks like, right? So, and here's what happens if your calibration is not great, right? Your fixations are all over the place, or they're so shifted with respect to the lines of text that the data is unusable. If we sort of led with that, we would have had better, well, less loss, right? We would have better retention of the data. A lot of data ended up unusable, right? You don't see it because we didn't include it in the output, or even what is shared. But yeah, and this is even so. Our criteria of including a participant were pretty lax, right? We wanted at least 5 good trials out of 12 to include a participant, right? So if we were happy with 5 texts with eye tracking data from 5 of the 12 texts, we would include those 5 texts in the output, right? So many sites had to collect 70 to 90 participants to get 50 good ones. We had to occasionally go back to our partners to ask, you send us 50, but of your 50, only 30 are good or 35 are good. So please collect some more. So that's perhaps the biggest hassle of the project. Now, yeah, some of the partners got creative and changed things around, which was more okay in their L1s, right? So especially the paraphrase text, of course, they were free to build them as they wanted. We made sure that there were no super long sentences or super short ones, but of course the original texts were original ones. Now in translations, we really wanted each sentence to correspond to a sentence, and occasionally we would have a situation when a full stop would be replaced by a semicolon or a hyphen or whatnot, right? Line breaks were occasionally moved, and especially in English, which came to our partners, right, as a package, right? So they could have used it without a change. So occasionally they did change it, and it's just difficult for programming for processing the outcome, right? More unnecessary steps than we would like to. Okay, so these were the technical things, right? The organizational. Well, like I said, we have over 30 authors in each of the papers, and one of them there's over 40. So to manage a project like this was actually easier than I thought there would be, and I was and I am extremely pleased and happy with our partners who contributed their data to the project. It's mostly when it came to collecting information on what compensation they gave to their participants, what their ethics protocol was, the funding, and so on, that we had to chase after some of the partners. One other thing I will mention is that well, there was no centralized funding for this project, and we never intended to have it, which is unusual, right? For a project of such a scope, it's much more likely that you would apply for some fund and you would distribute the money among the collaborators. And in the retrospect, I'm actually very pleased that we did not go the route of funding, and this is for a few reasons. First of all, to get funding would have taken a good couple of years, right? You write a grant, you apply, you wait, you're probably not successful the first time around. You have disappointed your partners because you're not successful the first time around. This whole business would have dragged on. See if I can stop sharing, right? So that's one thing. Secondly, the vast majority of the partners they had their eye tracking labs established, they had their arrays. It wasn't a huge burden on them to collect this data without extra funding, so they sort of covered it from the running of the labs. And of course, we encouraged these projects to become either bachelor's or master's projects in respective labs. That not only was it okay, it was actively encouraged. So so we only had to find funding for just a few partners, mostly in developing countries, and I was able to do so from some other operational budget in my lab. And again, because these are developing countries, the amounts were not huge, right? It's for better or worse, the labor, the accepted compensation in these countries is such for university students as research assistants that this never amounted to huge expenses. So we just took care of that locally, and that made for a sort of a light and fast project to run, right? Also, you might or might not be at this stage yet, but if you are a PI, principal investigator on a grant, and there's 20 labs or 13 labs on this grant, if there is a financial interest, right, things change immediately, right? So all the partners, for a good reason, want to know how much of the budget they're getting. Occasionally, they want to know that other people on the grant are not getting more or less than they do, and so on. So there was no incentive of that sort, and this removed the entire sort of, financial dimension of the picture. I think that's the reason we were fast and furious, right? We were able to collect the data in many countries relatively fast and to everyone's satisfaction, right? We were right. We had a protocol that we would send to all potential partners. We were extremely clear about what to expect as outcomes. So we were clear about not having the funding. We would say that in some cases we can cover participant fees or research assistant salaries, but more as an exception than a rule. Then we would say that if you participate, you can expect to be a co-author, one of the 30 or 40 co-authors on a paper of this sort. And so I think it was extremely important to make it very clear what to expect, right? We also made it very clear when to expect the data, right? So this, of course, is an open access project, but we made data open access to the world once the paper was accepted. Now, partners, of course, have every right to the access to the data beforehand, right? That's the fair advantage of having contributed to it. So going in, we made it very clear that they can always ask for the data process data from their own university. We'll provide it on the moment's notice, and that's in consideration of bachelor's or master thesis or whatever the case might be. And then we would say, well, at the moment when we submit the paper, right, that's when we make data public, well, not public, open to you, right? So the time between submission and acceptance, and it was a long time, was the time when they had an exclusive access to the data and could run their own studies, could run their own projects. The one restriction we imposed was that we asked that they don't publish anything until the big introductory papers are published, right? So do your analysis, you can prepare your paper and write it down completely. You're welcome once the big paper is accepted to sort of press a button and submit yours, but please don't do it beforehand so that we have a clear order of precedence, right? Yeah, so yeah, that's really what I wanted to tell you about MECO and the organizational part.